I've been fascinated by robots for a long time. I've always found it interesting that something as simple as walking or swimming throughout an environment presents such an enormous challenge to robotics engineers. Trust me, I should know. I've had first-hand experience banging my head against the wall trying to get the robot that you see in this video to navigate an underwater obstacle course. This was one of the biggest challenges of my life, but it was also one of the funnest. Going from absolutely nothing but an idea to something like this is incredibly fulfilling. This is why I'm deciding to design and build my own robotic quadruped, or in short, a RoboDog. I plan to document my progress on this channel and show you all how I'll be designing and building this thing. By the way, if you want to learn more about the autonomous underwater vehicle you're seeing, this is from a non-profit organization I established at my college called Mechatronics, where a bunch of students come together out of their own free time to build and compete in international robotics competitions. The people in this organization are some of the most passionate and smartest people I've ever met, and you should check them out. I put a link in the description. So for the RoboDog design, I will be creating a lot of new software from scratch, but I'll also be using open source or free software where appropriate, like 3D CADing tools, so that those of you who want to follow along can. I will also try to use parts that aren't as expensive, but I also want this to be a good quality RoboDog, so I won't be going as cheap as I can. This may mean higher quality motors and encoders, or higher quality cameras. Regardless, I will try to keep the budget low where I think is appropriate. So I've been thinking about several potential architectures and features for RoboDog. There are thousands of research papers and books out there that show different ways of how to model and control different types of robots. I would love to experiment with some of these robotic control laws out there, but to do that, I first need a robot. There are so many things you need to think about when it comes to making something like this, and it can easily be overwhelming. We need to consider what features we want, what processors you want orchestrating the system, what software you want to use, what motors to use, what type of encoders to get, how you want the RoboDog to sense and navigate the environment, how a user should interface and control it, and so on. But baby steps. First of all, I don't want this to be like a small toy. I wanted to make this more like of an industrial and sturdy design. One of the things that will help me facilitate this is a hardware and software co-processing device. So what do I mean by this? Well, there are commercial devices out there that you can buy that have both a configurable hardware and software element to it. The configurable hardware element is called an FPGA, and the configurable software element is just a processor like ARM, for example. The combination of an FPGA and a processor on a single silicon die chip is becoming more popular, and it seems to be the way that industry is moving as it gives you a lot of flexibility, power savings, and a quicker time to market with your design. If you don't know, FPGAs are basically devices that allow you to program circuits into existence. They're nice because they allow you to try out different circuitry without needing to respin various PCBs or solder various fixes on the FPGA. You just program the FPGA with a different bit stream and you get a different circuit. So with this in mind, I need to determine how I'm going to split up the workload on this heterogeneous system on chip, as in what will run on the FPGA and what will run on the processor. I've split up this block into two sides. On the bottom is the processing side, or the PS side, and on the top is the programmable logic side, or the PL side, which is the side that has the FPGA. It makes sense that there should be some form of user interface with the system, whether that be for configuring the system or controlling it. I feel this would be most appropriate on the PS side via some Ethernet interface. I could also create a web server in Python, for example, on the PS side to allow a user to interface or control the RoboDog. There should also be some form of navigation control that controls the control system algorithms. Now, some of the control algorithms could be facilitated on the PL side too, or it could be a hybrid where the PS side kicks off a chain of events in the PL. It really just depends on how easily some of these algorithms can be implemented in the PL. Generally, the PL side is much more difficult to program, especially for things like web servers and control system algorithms. Also, if things aren't working properly, it can be a lot harder to debug at the PL level. So for now, we'll leave things like navigation control and web server configuration on the PS side so that high-level languages like C or Python can help us create these elements. I also plan on having cameras be a part of the RoboDog so it will see the world. I was thinking of having this go into the PL region first and perhaps having an HDMI out as a debug interface so I can see a copy of what the RoboDog is saying. Also, having image processing in part of the PL may be nice. I think it will ultimately be a mixture of PL and PS for image processing though. There are some more advanced image processing algorithms I would like to implement that may be very difficult to implement in the PL, but simple things like cropping the image, basic color filtering, and so on should be doable in the PL and be much faster than doing it on the PS side. For some of the more advanced image processing algorithms, I may use OpenCV, which is more appropriate for the PS side, but I'll worry about that when I get a little bit more of the system defined. So the next thing I want is some form of data storage to store things like configuration information or processed images. This could be on the PS side, but I feel like I'll have more flexibility if I develop the data storage controller in the PL side. I can make things more secure by building a data storage controller that TMRs the data in non-volatile memory, which just means that instead of writing the data into the memory one time, I'll do it 3 times in different areas of the memory. TMR means triple modular redundancy, and you can sort of think of it as like a RAID configuration for hard drives in a server. This would help prevent data corruption, and implementing this in PL will provide me the option to do this optimally. I'm not sure if I'll go through with this though. This seems like one of those features that are lower in priority, but we'll see how I feel when I get further along in the design. Next, we have encoders, motor controllers, and limit switches. Encoders are devices that tell you the position of the motor shaft. The motor controllers will provide the necessary signals to drive the motors, and the limit switches will give you the ability to home the motors at a specific orientation. All these elements are pretty low level since they are all about either reading electrical impulses or driving signals to motors, so the PL region seems to be the appropriate place to develop this functionality. Lastly, I'd like the ability to stream the raw or processed images to some remote device or server. To do this, it would make sense to have some codec unit that encodes the image stream in some standard compression format like H.264 or H.265. I would want to compress the images first so that streaming would be faster and consume less networking resources. Compressing an image is a very repetitive algorithm, and it would probably be best carried out by something like the PL if possible, so I'm putting this image streaming in the PL region for now. So one of the last things I wanted to say before I wrapped up this video is none of this stuff is locked down right now. Everything I'm mentioning here may change down the line as we get further along in the design. And also, if you guys have any good suggestions and what additional features you think should be added to this design, let me know and I may incorporate them. I'll be putting as much time into this series as I can, and this video is just one of many I'll be making on RoboDog, so stay tuned if you want to see how this goes. I try not to ask this too often in my videos, but if you all think this is content worth subscribing to, please do. It really means a lot to me and will help free educational content like this get to as many people as possible. Thank you all for staying till the end, and I'll have another update shortly. Thank you.